Hello, Miss Larry, Miss Larry, are you alright?
Yeah.
Okay, what's prefix? We talked about this prefix before. Prefix sum. Prefix. What's prefix? For example, what's prefix? Like, look. Eric. What's the prefix of the Eric? How many prefix? How many prefix of these? Four. What are those? I see. Yeah. And we also talk about suffix. Yeah. What's the suffix of this? What's the suffix? Come on, the opposite. C. Yeah, I see. I see. Well done, good job. You understand this. Okay, and we also talk about the prefix sum. Okay, we talk about prefix sum today. Remember? Why do we need a prefix sum? Suppose we have an array like 1, 2, 3, 4, 5, 6, 7. Okay, so this is an array with n items. Okay, and if I tell you like I want to calculate the sum between any ranges. For example, I want to calculate the sum between 3 to 5. So what's the sum? 3 plus 4 plus 5, right? Yeah? 3 plus 4 plus 5, which is 12. What's the time complexity if I just do it like that, brute force? If you tell me, okay, I want to start from the lower range is from 3, the upper range is 5, and can you tell me the sum? And then we just do a loop for I in range from 3 up to 5, okay? And then sum answer plus equals the value, yeah? What's the time complexity for this one? What? N, well done. Because this, if the lower range is 0, right? Upper range is the n, right? And then this eventually will be you looping all the I elements in the array and then getting this sum will be O(n), which is very slow, not very fast. Okay. So how can we do?
N slow?
If n is a median, it's a slow, right?
Yeah, because it has loads of things.
O(n) is slow compared to O(1). If we can do it O(1), how can we do this O(1)? If we already know, if we do this, if we are calling this n many times, yes. If we want to speed up the calculation of such things, the sum between any range, okay, Eric? So how can we do this? Remember we talked about the prefix sum. How can we calculate prefix sum? So look, what's the prefix sum? What's the prefix sum of this? Eric, can you tell me?
1, 3.
How do you get a 3?
1 to 3, easy.
Okay, 3.
6.
How do you get the 6?
3 plus 3, 6.
Yeah, it's 1 plus 2 plus 3, yeah? So basically the values will be updated to the sum of all the elements from the beginning up to it, right? So what's next? 10, yeah?
10.
And?
Yeah.
15?
15.
21?
28.
Wait, okay, so got it. So why is this useful? Because we only calculate this once, right? We only calculate this one. Then we can use this to calculate the sum between 3 to 5. How do we get this? How do we get the sum between here? Alright? The sum of these 3 elements, is it equal to the sum of these 5 elements? Look, minus these 2 elements. Alright?
Yeah.
Look, I want to get the Ryan, Eric, look. Ryan, look. The sum of 3, 4, 5, right? Ryan?
Yeah.
Is it equals to the sum of 1 plus 2 plus 3, 4, 5, minus the sum between 1 to 2, right? So, okay, so can you tell me the sum of 1 to 5, which is?
15.
The sum of 1 plus 2?
3.
Yeah, we just look it up, yeah? So the sum of 3 plus 4 plus 5?
12.
12. Which one is faster?
This one.
This one. What's the time complexity for this one?
1.
1, yeah. If we are not considering the building up, because we only need to build this up, what's the time complexity to build the prefix array? What's that? And yeah, because we need to go through this array one. Okay. So okay, let's review this bit. How do we calculate this the prefix sum for the array? Okay. How do we calculate it? It's easy, yeah. Define prefix, build the prefix, okay, prefix sum. If this is the data, yeah, data. So how do we do this, Eric? Look. How do we do this? N equals length data, right? If n equals 0, we just return, okay? Because it's we just return nothing, okay? And then what should we do? Alright? For I in range, we start from the first one, right? And up to n. Can you tell me what to do? Data what? Look. 1, 2, 3. We start from the second one. Second element, look. Yeah? So data I equals what?
1.
Sorry? Data I equals what? I need to plus the previous one, right? Right? And data I plus equal what?
I minus 1.
Data I minus 1, yeah. That's it. Look, remember we use the function, remember? We can, remember we talk about the accumulative function, right? This can be replaced by what? Accumulate. Remember, we can from iter2 import accumulate. What's accumulate mean? I mean accumulate. What's this function mean? Accumulate.
It means that
Accumulate, you know, bits by bits, I put it together, right? So all these can be changed into what?
it's rubbed them out.
This return data, yeah, this return data, and then I can just do this. Return. Convert to this, because accumulate return the iterator. Accumulate data, and that's it. Yeah, we talked about this before. So this thing, these 3 lines is equals to this accumulate. Okay, like we have a built-in function. Okay, okay, let's review. Okay, let's talk about the subject today, which is the prefix sum for a metric, which is a 2D. Remember, we talked about array. This is 1D. Yeah, we talk about array. Array is 1D. Yeah, one dimensional. Okay, don't touch it. It's shaking. Okay, the array is one dimensional, right? Alright, 1D array. 2D. What's 2D? Alright.
2D is 2D.
2D. Look, 1D a line. 2D a plane. 3D. You know, we are living in a 3D space. Right? 3D, yeah? X, Y, Z, right? Look at 1D, X is a line. 2D, X, Y. What's 3D? X, Y, and then there's a Z. I can't put it here. You know, you put a, you know, this is a cube, yeah? Cube is 3D, yeah? 2D, square. 1D, a line. Okay? Yeah? Got it? That's the basic. So 2D metric, we have a 2D X and Y. So look at metric. 0, 1, 2. 2, 1, 4. That is a 3, 2, 1. Okay. This is the 3 times 3 metric. How many rows does it have?
3.
3, yes. The index will be 0, 1, 2. What's the, how many columns does it have? 3, yeah?
3.
So 0, 1, 2, the index. Okay, so we want to change this to metric, to convert it to a prefix metric. What's a prefix metric? Prefix sum metric. So every element will be updated to the sum of all the elements from the top left corner to itself. Well, for example, like 0 will be 0. And here, I want to update this one will be what, Eric? 0 plus 1, okay? And here, look, this is the first row is the same as we talk about the accumulate function, right? Eric, look, will be 0 plus 1 plus 2, right? And then look, took 0 plus 2. Here will be the sum of these 4 elements, right? 0 plus 1 plus 2 plus 1. And then 4 will be the sum of all these 6 elements, okay? And here will be 0 plus 2 plus 3, yeah? And then 2 will be all these 6 elements, right? And 1 will be all the 9 elements. That's it, yeah? Okay?
So why don't you write
It's too many, okay, too many.
Is it 1?
Okay, so how can we do this? Is there any idea? I mean, yeah, I know brute-forcing. Then how do we do this? We can do what? Yeah, because this is yeah, each element, right? Eric, right? Each element will be the sum. Will contain the sum of the previous one, right? So if we update look for each row, Eric, what happened? If for each row, if I do this accumulate thing, like the prefix sum of 1D, right? Then I can do this. Look, how can I do this? Look, 0, 1, 2. Yeah. If I do it 2 steps, the first one is I do this for each row. For each row, I do the accumulate. Can you tell me for the first one, what's the accumulate? 0, 1, 2. 0, 1, and then what?
2.
No. 2 plus 1, 3.
Oh, I thought you.
Okay.
Right,
2,
all over
2,
again.
and then what? 2
2
plus 1, 3. Yeah. And then
3.
and then what? 2 plus 1 plus 4, 7. Right?
7.
And 3. 3 plus 2.
5.
And
6.
way down. Okay. So now each row will be having this prefix sum, right? And what should I do next?
Why is that 6 supposed to be bigger?
Yeah, good question. This is the first step. It's not yet finalized yet.
Oh.
Yeah, I'm just doing this for each row, right? Containing the sum of the prefix sum. And then can you guess what's next? Can you guess what's next?
I'm not sure.
Come on, if I do the rows, and what happened to the next?
Columns.
Where down? How do we count the columns? We just wrote it, yeah? So each one, I just do this, yeah? Got it?
Yeah.
So how can you tell me what's next? Okay, can you tell me what's next? 0, and then do this, what's next? 2, and what's next?
5.
Where down? Yeah, you got it. 1, what's next?
4.
What's next?
9.
Where down? 3,
10.
10.
16.
Okay, let's just check. 10 is it the same? Okay, look. 0 plus 1 plus 2. 3 plus 2. 5 plus 1. 6 plus 4.
10.
Yeah, you see? We got this correct. Let's check this again. Is it 9? 0 plus 1.
2.
1 plus 2. 3 plus 1. 4 plus 3. 7 plus 2.
9.
Got it. Yeah? Does it make sense? So first of all, we do the rows accumulate, and then we do the columns accumulate. Simple. Right? Got it? What's the time complexity for this approach?
ORC.
What's R and C?
Rows and columns.
Well done. Good job. Okay, let's do this. It should be quick, okay?
It should be slow. Yeah, exactly. Slow.
You want more minutes, right? Yeah, then you'll be a good boy, okay?
Because we want to play Pokemon Go like an hour or more.
Okay.
Yeah.
Metric sum, okay, let's do this. Metric.
Scratch.
Let's do this.
Scratch.
M, okay, M, okay.
I'm doing number 3rd.
If the metric is empty, then we just simply return empty, yeah? Okay? Okay, then rows.
It's the same as
Rows equals length M. And then if 0 equal,
rows.
then we return, right?
Return matrix.
Yeah, the matrix M.
Columns equals length matrix 0.
What does this mean? Runs matrix. Eric, 0. And then if 0 equal columns, then we return matrix. Okay. Okay, now let's do this for each row, right? We want to do this row, right? For R in range what?
Yeah.
In range what?
For R in range rows. For C in range.
What? Okay, stop it. For R in range though, for each row I can do this accumulate, right? We can do this for C in range from star 1 to columns, and then metric R C plus equal metric R C minus 1, right? And we also can do this, look, metric R equals list
Accumulate.
accumulate. So this one is better, yeah? Okay? Alternative, look, we can do this for C in range, start from 1 to columns, and then metric R C plus equals metric R C minus 1, right? This thing, remember we talked about this 5 minutes ago, okay? Okay, then after we do the rows, we do the columns, yeah? So for what? Let's do for R in range from the first row, right? From the second row, we're not doing it from the first row, from the second row, right? From the second row, and then rows. And then we need to do this for columns. For C in range columns, right? And what do we do? Metric R C plus equal metric what? R hour, and see what? Hours, hour. The previous row is what? Yeah, well done. And then return metric. Okay, so let's see. Why do we need this metric? Remember, what's the advantage of using this metric previous for the 1D? We want to calculate this. We want to calculate the sum between any range. In a range in one constant term, right? For the metric, it's the same thing. Look. 1, 2. If it is, look, Eric.
And battle.
Eric?
Cake. Olivia.
Let's write this, okay? Let's just write some element, okay? Okay, so look, if I want to get the sum of these 4 elements, Eric? Eric?
Yes!
If I want to get the sum of these 4 elements, what does it equal? Can we use this for prefix sum?
It equals 28.
No. Yeah, I know, but how can we do this? How can we do this? Is it equals to...
What are those x's?
No, I'm talking... Look, remember I talk about this. 1 plus 1, 2, 3, 4, 5, 6. I want to calculate the sum between 3 to 4, right? 3, 4, 5. Is it equals to this sum minus this sum, right? Yeah. This is the same thing. I want to calculate these 4 elements. Is it equals to the sum of these? Right? But I need to look at the sum of these and then minus what? Minus sum of these, right? And then minus this bit, right? Yeah? Got it, Eric? Does it make sense, Eric? Yeah, so if I want to calculate this 4 sum, I need to minus these 3 bit, yeah? These 3 bit. These 2 bit, okay? But usually you want to calculate minus what? Minus this bit, the sum of up to this point, and you want to minus this point and this point, okay? Got it? Does it make sense, Eric?
That's it for today.
Okay. What?
That's a heart.
That's what? Come on, MRC equal what? MRC what? Plus equal what?
Plus equal matrix R minus what? C! Return.
Okay, that's it for today. Good job.
Good
job today. Bye bye.
Wow. Yeah.
Bye bye.
Bye.